Hello everybody. Welcome to a new episode of Nile Tech. With your AI host Sarah. We will explore various fields of information technology and technology updates locally and internationally. We will engage conversations with many experts in this field. In addition, we will know about everything new in the field of AI, machine learning, information and communications technology, and artificial intelligence. At Nile Tech, we will follow events, cover activities, and attend exhibitions and conferences on everything related to artificial intelligence, mechatronics, and information technology. Just stay with us.
ICT Minister meets GCSE top performers. The Minister of Communications and Information Technology, Amr Talat, has met with the General Certificate of Secondary Education, Thanawea Amma, top performers of 2024. The ICT Minister welcomed the parents and students, commending their determination and ambition to shape a successful future by pursuing their education at promising universities. He emphasized that such dedication is essential for achieving excellence in their future careers. The Ministry of Communications and Information Technology, MCIT, explained that the ministry's vision is to nurture students' self-learning capabilities and equip them with the skills and expertise required to compete effectively in the global job marketplace. This is achieved by providing them with comprehensive skills, integrating knowledge, expertise, and soft skills. The ICT Minister highlighted that the ICT sector has been the fastest growing state sector for the past 6 years. He noted that this growth is attributed to the pivotal role of ICT as a cornerstone among all state sectors, with ICTs being essential for driving development and refining skills across various professions, thus creating a promising opportunity for a successful and dynamic professional future. Egypt enjoys a large talent pool, Talat underlined, explaining that numerous companies employ Egyptian talents to export IT services to clients worldwide, with many leading tech countries experiencing a growing demand for skilled professionals. Talat held an open discussion with GCSE top performers and their parents, addressing their inquiries about the essential skills and future developments in the ICT job market driven by technological advancements. The ICT Minister referred to the ministry's initiatives that focus on building digital capacities across various age groups, aiming to expand the skill pool in all ICT fields. The Generations Mobile Lab is affiliated with the National Telecommunications Institute, which was established in the new administrative capital in partnership with major telecommunications companies in Egypt. The lab is the first of its kind in Egypt and the region for practical training in the field of mobile networks, and aims to provide a real environment for training on the latest mobile network technologies, such as 5th generation and others, to prepare trainees for the labor market and future jobs. The lab includes real mobile towers and advanced devices and is characterized by the presence of programs that allow the trainee to control each component of the network, identify and repair faults, and manage the network. Artificial wombs, also known as exo-wombs, represent a groundbreaking development in reproductive technology and neonatal care. Currently, the most significant advancements in this field are centered around creating environments that can support the development of premature babies outside the human body. These artificial wombs aim to mimic the conditions of a natural womb as closely as possible. They typically involve a biobag filled with a fluid similar to amniotic fluid, providing nutrients and oxygen while removing waste. The goal is to provide a more controlled and stable environment for premature infants, improving their chances of healthy development. The working principle of an artificial womb is to replicate the physiological conditions of a natural uterus. This includes maintaining the appropriate temperature, humidity, and fluid composition, as well as providing the necessary mechanical support and protection. Researchers are also exploring ways to simulate the maternal placental interface, ensuring that the fetus can receive the right balance of nutrients and hormonal signals for proper growth. Looking into the future, artificial wombs could evolve to have broader applications beyond neonatal care for premature infants. One potential area is in fertility treatments, where artificial wombs could offer an alternative for individuals who are unable to carry a pregnancy. This could be a significant advancement for couples facing infertility issues, single individuals, or same-sex couples wishing to have biological children. Another intriguing possibility is the use of artificial wombs in space exploration. As humanity looks towards long-term space missions and colonization of other planets, the ability to safely gestate offspring in space environments becomes crucial. Artificial wombs could provide a viable solution for human reproduction in space, where the absence of Earth's gravity and other environmental factors make traditional pregnancy challenging. Nanotechnology is an atomic or molecular scale, has seen significant advancements in recent years, opening up a myriad of possibilities across various fields. This technology works by controlling materials at the nanoscale, typically less than 100 nanometers in size, to create new structures, materials, and devices. At this scale, materials can exhibit different physical, chemical, and biological properties compared to their larger-scale counterparts, enabling unique applications. One of the most exciting current advancements in nanotechnology is in the field of medicine. Researchers are developing nanoscale drug delivery systems that can target specific cells or tissues, such as cancer cells, improving the efficacy of treatments while minimizing side effects. Another significant development is in the creation of nanomaterials with extraordinary properties, like graphene, which is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. Graphene is renowned for its strength, flexibility, and conductivity, and is finding applications in electronics, energy storage, and even water filtration. Looking into the future, nanotechnology could evolve to have a transformative impact on various industries. In healthcare, we might see the widespread use of nanobots for diagnostic and therapeutic purposes. These microscopic robots could perform complex tasks within the human body, such as repairing damaged tissues or directly attacking pathogens, leading to new frontiers in medical treatment. In the realm of environmental sustainability, nanotechnology could play a crucial role in developing new methods for water purification, air filtration, and energy generation. Nanomaterials could be used to create more efficient solar cells, batteries, and fuel cells, contributing to the transition towards cleaner and more sustainable energy sources. Furthermore, nanotechnology could revolutionize the field of electronics, leading to the development of smaller, faster, and more efficient devices. This could include everything from advanced computing systems to wearable technology that seamlessly integrates with the human body. The Internet of Things, IoT, refers to the growing network of interconnected devices and objects that can collect and exchange data using embedded sensors. These devices, ranging from ordinary household items to sophisticated industrial tools, are connected to the Internet, allowing them to send and receive data. This connectivity enables a level of digital intelligence in these devices, allowing them to communicate real-time data without involving a human being. One of the most interesting current advancements in IoT is the integration of artificial intelligence and machine learning. This allows IoT devices to not only collect data, but also to analyze and learn from it, leading to more efficient and intelligent systems. For example, smart thermostats can learn a user's preferences and adjust the home's temperature automatically, or industrial IoT devices can predict maintenance needs for machinery, reducing downtime and saving costs. Looking into the future, IoT could evolve to become even more integrated into our daily lives and the infrastructure around us. One potential development is the concept of smart cities, where IoT devices are used to optimize traffic flow, manage waste, improve energy efficiency, and enhance public safety. This could lead to more sustainable and efficient urban living. Another area of growth could be in healthcare, where IoT devices could monitor patients' health in real time, providing data that can be used to personalize treatment and predict health issues before they become serious. Wearable devices could track vital signs, and smart sensors could monitor conditions in a patient's home, improving the quality of care and patient outcomes. Furthermore, IoT could play a significant role in agriculture, with sensors monitoring soil conditions, crop growth, and livestock health, leading to more efficient and sustainable farming practices.
Good afternoon and welcome to Nile TV. Today we have a special guest with us, Professor Syed Abdulgaber, Professor of Information Systems, Faculty of Computers and Artificial Intelligence, Helwan University. He is here to discuss the key technologies of artificial intelligence. Prof, what's the relation between the machine learning and the deep learning?
Machine learning is a method where the target is defined and the steps to reach that target is learned by the machine itself by training on methods from neural networks, statistics, operations research, and physics. For example, to identify a simple object such as an apple or orange, the target is achieved not by explicitly specifying the details about apple or orange, but as we teach a child by showing him multiple different pictures of apple or orange, and therefore allowing the machine to define the steps to identify it. Machine learning behind a wide variety of tools that many of us uses every day. It's present in our social media channel, customer service interaction, and data analytics. It allows companies to automate a wide variety of tasks that making them more efficient and cost-effective. Machine learning is most helpful when simple rules or computation can't be used to predict a target value, or when looking at a large dataset. There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. On the other hand, deep learning mirroring the processing that happen in the human brain. A brain contains millions of neurons that work together to process and analyze information. Deep learning uses artificial neurons that process information together. Each artificial neuron or nodes uses mathematical calculation to process information and solve complex problems. This approach can solve problems or automate tasks that normally require human intelligence. At the end, deep learning is a subset of machine learning.
And what are the applications of deep learning?
There are many applications of deep learning. We'll talk about some of it. First, image recognition. Image recognition is an example of a computer vision algorithm which breaks an image down into different aspects that are used as a reference points. The features of the images are then matched with features of available samples to produce a suggestion. For example, Facebook provides a feature of an auto-friend tagging suggestion. Whenever we upload a photo with our Facebook friends, then we automatically get a tagging suggestion with name. The technology behind this is face detection and recognition algorithms. It's based on the Facebook project named DeepFace, which is responsible for face recognition and person identification in the picture. Second application is the human genome. The human genome is one of the largest data sets ever studied. Humans contain over 20,000 different genes, each of which has potential for variation. Deep learning allows researchers to better understand different genetic types and abnormalities as they analyze and understand vast data sets. For example, deep learning helps scientists identify the genetic variants shared in individuals with traits that those scientists are studying, like hemophilia or diabetes, allowing them to better understand where in the genome this disorder originates. Occasionally, it can help researchers understand why they occur in the first place. The third application we'll talk about it is deep learning application in education. Deep learning can help educational institutions impose process-based tasks and more student-focused initiatives. Statistical models can help understand student progress and needs, while scheduling algorithms can help to create more efficient and streamlined schedules for institutions of all sizes. The last application we'll talk about it is the computer vision. Computer vision uses deep learning techniques to extract information and insight from videos and images. Using computer vision, a computer can understand images just like a human would. You can use computer vision to monitor online content for inappropriate images, recognize faces, and classify image details. When machines can process, analyze, and understand images, they can capture images or video in real time and interpret their surroundings. It is critical in self-driving cars and trucks to monitor the environment and make split-second decisions. Computer vision captures and analyzes visual information using a camera and digital signal processing. It can be compared to human eyes, but it is not bounded by the human limitation, which can enable it to see through walls.
What does the neural network means, and what are its types?
A neural network is a type of machine learning that is made up of interconnection units that process information by responding to external inputs, relaying information between each units. The process requires multiple passes at the data to find connections and derive meaning from undefined data. The data is fed into the first layer of a neural network, with each pattern deciding, then passing that information onto multiple nodes in the next layer. Some of the most common type of artificial neural network are feed-forward neural networks. It is one of the oldest forms of neural network, with data flowing one way through layers of artificial neurons until the output is achieved. In modern days, most feed-forward neural networks are considered deep feed-forward with several layers. Feed-forward neural networks are typically paired with an error correction algorithm called backpropagation that, in simple terms, starts with the results of the neural network and works back through to the beginning, finding errors to improve the accuracy of the neural network. The second type we'll talk about it is a recurrent neural network. Recurrent neural network differ from feed-forward neural network in that they typically use time series data or data that involves sequencing. Unlike feed-forward neural networks, which use weights in each node of the network, recurrent neural network have memory of what happened in the previous layer as condition to the output of the current layer. Recurrent neural networks are often used for speech recognition, translation, and to caption images. The last type we'll talk about it is convolutional neural network. Convolutional neural networks include some of the most common neural networks in modern artificial intelligence. It is most often used in image recognition. Convolutional networks use several distinct layers that filter different parts of an image before putting it back together in the fully connected layers. The earlier convolutional layers may look for simple features of an image such as color and edges before looking for more complex features in additional layers.
How can we differentiate between the supervised learning and unsupervised learning?
Well, supervised learning is a machine learning model that maps a specific input to an output using labeled training data. In simple terms, to train the algorithm to recognize picture of cats, feed it pictures labeled as cats. Unsupervised learning is a machine learning model that learns patterns based on unlabeled data. Unlike supervised learning, the end result is not known ahead of time. Rather, the algorithm learns from the data, categorizing it into groups based on attributes. For example, unsupervised learning is good at pattern matching and descriptive modeling. In addition to supervised and unsupervised learning, a mixed approach called semi-supervised learning is often employed, where only some of the data is labeled. In semi-supervised learning, an end result is known, but the algorithm must figure out how to organize and structure the data to achieve the desired result.
What about the speech recognition?
Speech recognition software use deep learning models to interpret human speech, identify words, and detect meaning. Speech recognition is a process of converting voice instruction into text, and it is also known as a speech-to-text or computer speech recognition. You can use speech recognition in technologies like virtual assistant and call center software to identify meaning and perform related tasks. For example, while using Google, we get an option of search by voice. It comes under speech recognition, and it is a popular application of deep learning. At present, deep learning algorithms are widely used by various applications of speech recognition, such as Google Assistant, Siri, Cortana, and Alexa are using speech recognition technology to follow the voice instructions.
Can you tell me about the natural language processing?
Natural language processing is broadly defined as the automatic manipulation of natural language, like speech and text, by software. It uses deep learning algorithms to interpret, understand, and gather meaning from text data. Natural language processing can process human-created text, which makes it useful for summarizing documents, automating chatbots, and conducting sentiment analysis. One of the well-known examples of this is email spam detection, as we can see how it has improved in our mail systems. This technology gives the computer the ability to analyze, understand, and generate human language, including speech. The next stage of neural language processing is natural language interaction, which allow humans to communicate with computer using normal everyday language to perform tasks.
Thank you for having me. It was a pleasure to discuss this important topic. And thank you, our viewers, for joining us on Nile TV. Stay tuned for more enlightening conversations. Good night.
It is the end of this episode of Nile Tech. See you in a new edition with more updated subjects related to information technology and artificial intelligence. Waiting for your comments and opinions on the program's Facebook page.